Good morning, everyone. How are we doing? Everybody okay? You can raise a hand or something, or you're right, Prince. Yeah, you okay?
Yeah, I'm good. How are you guys?
Yeah, not too bad. Not too bad. Alex, Pauline, Elsie, everyone all right?
I'm good. And you?
Yeah, not
Yeah.
too bad. Not too bad. Is anybody watching in bed on their laptop, still rubbing sleep out of their eyes? So just letting a few people join. But this morning, Blaze, we received the updated and the current slides for today's session. They have been emailed to everybody this morning. So everybody who is registered would have the slides from last week's session and also today's session. And we promise you that we will get next week's slides to you earlier in the week. Okay. I promise you. So anybody, if you've not checked your emails from last night, now is the time to do it, because the slides for this week should be are in your inbox, as well as pertaining to last week as well. Okay. Furthermore, anybody that wasn't here, let me just let some more people in.
Yeah, we have a couple of some new people today.
Yeah, got a couple of new people today. So basically, my name's Ian Benjamin. I'm losing my voice. Just bear with me. My name's Ian Benjamin. That's better. My name's Ian Benjamin. Myself and Blaze Nanji are the founders of the Black Data Professional Network, BDPN. We've been in existence for a year now, and we have, I think, 1,100, 1,200 members that are based across the UK and overseas as well. The focus is to upskill, mentor, provide support for all of you. Everyone's on a different journey, so we haven't got a magic wand to help everybody at the same time. But what we do is provide training, online training, webinar, seminar, support, career advice. We've held events with Salesforce, done events with Lloyds Bank from a career perspective, and provide all free training to help everybody on their career in data science, as a data analyst, regardless of where you are on that journey. And we are very, very fortunate to be blessed to have Abdul as a lecturer. Abdul's from Nigeria originally, and he's a lecturer, a teacher who loves data. He just loves it. Very, very knowledgeable individual, and he's sharing his insights with you all over the next 11 weeks. Last week was the first week. If you want to view the video or the session from last week, you can access that from the BDPN website, thebdpn.com, thebdpn.com, and then go to the content hub and then look through there, and you can watch back the session from Abdul from last week, which was an introduction to Python. Okay, so there's no cost for that. Everything's free that we're doing. So, but welcome to anybody that's joining for the first time. Abdul, we're blessed to have him here. He's going to be taking you on a journey of the fundamentals of data science. And so without further ado, I'm going to hand over to Abdul, and I'll see you guys a bit later on during the session. Thank you. Or actually, any questions? Any questions from anybody? Don't be shy. Any questions from anyone? Any suggestions?
Yeah. I want to know, is it too late for someone to register for the course?
No, they can still join. Yeah, they can still join. So have you got the registration link, Alex?
Yes, I do. I want it for a friend, so I just wanted to confirm so that I can forward it to a friend.
Yeah. What I'm going to do, actually, I'm going to put it below as well
That'll be fine.
in the chat. I'll try and find it here, put it in the chat. So if anybody else wants to share the link to join, then it'll be in the chat below. I'll do that before I jump off. Anybody else got any questions at all? Anyone? And
I have one question. I've like had a brief look at um the PowerPoint, the PDF. So are we gonna like, I know the way we didn't like go straight off the PDF PowerPoint, so we're gonna like refer back to it slightly, some of the stuff for this week's one. Because I know in terms of the order, I can see like some of the stuff we didn't actually go through last week. So and it's not exactly in order. So I was just wondering if we're gonna go and refer back to it.
Abdul, what's a question for you, buddy?
Yeah, the aim is to go through last week, what we did last week, and revise everything together. Those that we have not done, we're gonna do everything when we encounter anyone in the slide. So there is no problem. We go through everything as well.
So it's going to be like a recap of last week and also some new content for this week as well. Is that right?
Yeah.
Okay, cool.
Okay, thank you.
Is that right? Has everybody else checked their emails and has everyone got access to the slides?
Yeah, received the slides. Yeah.
Yeah. Okay, cool. Look, let's take Abdul over to you, buddy. And hope everyone else gets some benefit and enjoys today's session. Thanks very much.
So you're welcome. So we're going to be going through the last week's slides, because in the slide there are some things we didn't talk about last week, but just bear with us. This week we're going to provide the slide, and everything is going to be timely henceforth. So everyone has been working to ensure that you all have the slide before we start the class. So I believe next week is going to be better off. So before we start anything, let's quickly go back to our browser and look for Google Colabs, as we did last week. So I'll be sharing my browser with you, so you see the way for some people that are just joining us to know how we get to the Google Colabs. I hope you are all hearing me.
Yeah, sure.
Hearing you.
Yeah, please, I want to share my kindly allow me to share. Kindly allow me to share my screen. Please, I can't share my screen for now.
Try now.
Okay.
Does that work?
No.
Should do. You sure?
Yeah, still disabled. Maybe I should restart, right?
No, don't do that. Stay there. I don't know what that is.
Okay.
Hang on. Try now.
Yeah, good now. It's fine. So I'm sure you can all see my screen. Please respond. Can you all see my screen?
Yep, yes, screen.
Can you see this?
Yes.
Yes.
Yeah. For people that are just joining us, you have to just type Google Colab. Then enter the Google Colab. So look for the Google Colab here, the second one. And then new notebook. So you should get something like this. Are we all on the same page?
Yep.
Yeah, so you should have something like this, or if you like, you can name it professional network 2. That is the name I want to give to it. So last week we talked about this shell. This Google collapse, you were told that this is called shell. This place where we can type our code, they are referred to as shell. And if you want more shell, you know, here we now have just only one shell. If you need more shell, you just have to press this plus. So when you press it, it's going to add more shell to it. So you can type in the shell, because that is what we're going to be using for our coding. So let's must be shared last week slide. I will be sharing the slides. You guys will be looking at the slide together with the Google Colab. So on the slide you have with you, so you can see my screen, right?
Yep. Yeah.
Yeah.
Yep.
Yes.
So we have this slide. These are how we did in our last class. So we talked about Python fundamental. And in the Python fundamental, we talked about the data types in Python, building function, variables, and some of them that we maybe for some reason we have skipped. We are going to talk about everything together today again. So though it's going to be very fast because we already have the idea of what we're talking about. Last week we talked about the data types. And in data types, we try to look into numerical data types, which are of the type integer, float, and complex. The integer, they are referred to as float number, while the floats, they refer to as number that has a decimal point. Then complex is a complex number. Then we talked about text type of the type string. The string, they are things like words like hello, they are not numbers. However, we were also made to know that some string, that is the way you can put your number to become a string. All of them have gotten the way we declare them. We also talked about the sequence type, the list, tuple, and range, which we will talk more on them today. Then the mapping type, dictionary, the set, and the Boolean. Those are things we talked about in our last class. When you see an integer, what you can easily use to know an integer is just an ordinary number that would be added in a variable. And when you see a float is going to have a decimal place, something like 2.5 is going to be a float. When you have 2, or just 2 is going to be a number, just an integer, because it's not having the decimal place. When it has a decimal point like 2.5, it's no more going to be an integer, it becomes a float. And then a complex is a type of a numerical data type that has a complex data type, like J on it. It has a real part and a complex part. Like when you say 2 plus 3J, the 3J is not just ordinary number, it becomes a complex number. So we demonstrated those in our last class, which I will still look into them somehow today. Then we talked about the string. We already said string, they are words. And for you to declare a string, in Python, you use a quote, either a single quote or a double quote. Once you put the quote, it automatically becomes a string. And then we also talked about the list. List as a square bracket. We have gotten the different type of bracket, round bracket, square bracket, angle bracket, curly bracket. So all these brackets dictate the type of data type we have in a sequence. If it is a square bracket, we have a list. If it is a round bracket, we have a tuple. If it is angle bracket, if it is a curly bracket, you have a dictionary or a set. So last week we tried to look into what a dictionary look like and what a set look like. And then Boolean, they are simply true or false. We are going to be using all these in our control flow. Before I move to the second slide, quickly permit me to share the new notebook so that I quickly demonstrate what I explained just now. Yeah. Talking about integer, we say integer, for example, my int is equals to 35. 35. This is an integer because it's a whole number. So if I come down again and I say my integer 2, or I just call it my number. So let me change this to Kamek case. My number is equal to 5.
Sorry, we can see your screen.
Oh, you are not seeing you can't see my screen, right?
Yeah, we're seeing by the slides.
Okay, can you see this now?
No.
No, let me stop sharing.
Yeah, that's fine.
There you go. Yep.
Okay, you can see it now. Now, I say my integer, int, is equal to 35. The 35 is an integer because it has no decimal place. That is why we call it an integer. If I like, I can say is equals to 40, is equals to 30, all these are integer. Is equals to minus 5 is an integer. Is equals to minus 10 is an integer. Is equals to 99 is an integer. Is equals to 1000 is an integer. Minus 1000 minus 100 is an integer because it has no decimal place. Now, when you come to this other part and where I say my number, if I say my number is equals to 5.8, this becomes a float data type, no more an integer because it has a decimal place. And by the time I come down again, I say my variable, for example, I just want to say my variable is equals to hello. Hello.
Hi, we can hear you.
You can't hear me?
We can.
Can you hear me now?
Yes.
Okay. So if I come to line 3 and I say my variable is equal to hello world. This is no more an integer, neither is it going to be a float. It becomes a string because these are words, right? So this is a string. There is a way we declare our string. If I come and say my number 2, my variable 2 is equal to hello world. So the difference between the first one and the second one is that the first one I use quotes, that is having the double quote. And the second one I use just a single quote, right? Hello, please speak up.
Yes.
Yeah.
So both are still integer and they are still string. String can be declared either using a single quote or using a double quote. Either of the two, they are both correct as a string. So for you to perform any operation on any of your variable, you have to run the shell first. For example, if I run this shell, you are going to see that it's going to be marked. So it's trying to run. If I did not run it, it has been marked. It means I can now perform operation on that my integer, because if I did not run it and I just start to perform operation, it's going to flash an error. So now if I want to create another shell behind it, I can say the type. You know what type means? How to check the type of the variable we have, type of my int. So if I check this type of my int, it's going to tell me that this type of your int is an integer. Let me run. This becomes an integer. The same thing if I run this and I create another empty shell under it to say type of my number. My number, if I run it, is going to tell me that this is a float because it's 5.8. This is a float. And if I run this one as my variable, and I create another empty space, empty shell to run the type of my variable, okay, my variable is going to tell me that this is a string because you have gotten the quotes. So if I run it, this becomes a string. Oh, no, I'm not running that. So this is a string, str. So it's the same way if I run this one, hello world. You know, my variable 2 and my variable 1, the difference between them is just the nature of the quote I use, the double quote and the single quote. So we just want to tell ourselves here that you can either use a single quote or double quotes to denote a string. Okay. So if I run type, the type of my string, my variable 2, this will be telling us that it's also a string. Oh, there is an error. What is the error? My var, okay. Oh, the spelling is wrong. You know, I've said capital letter V, my variable 2. This is a string. So telling us that either using whether we use a single string, single quote, or we use a double quote, we're still gonna get a string. There is this we also said in our last class that we can also set a number to become a string. When I say string, if I come and have something like str number is equal to, for example, 5, or maybe 521, for example. Normally, 521 is numerical. But once you put it in these codes, either a single quote or double quote, it's no more going to be a numerical number. It becomes a string. It's no more numerical. So if I run string num and I try to look for the type of string num, if I run it, it will be telling me that this is a string because it's no more a number. I put it in a code. Of course, you should remember that what denotes a code is either going to be a single, what's define or declare a string is either going to be a single quote or a double quote. Once you put it in a single quote or double quote, it's no more a number. It becomes a string. Now, another thing we did in our last class was that we talked about we have talked about string, float, integer. We also talk about complex. My complex, for example, if I have my complex, and I say my complex is 5 plus or 5 minus 14j. Immediately you write a number like this. In your ordinary mathematics, you know, this is no more an ordinary number. This becomes a complex number, because you put the alphabet J. This is the complex part of this number, while this is a real part of the number. This number has gotten a real and a complex part. This type of number is what we refer to as a complex number. So if I run it and I try to call type on it, the type of my complex, if I run this becomes what? A complex number. Complex. It's not just an ordinary number, it's a complex number. And again, we talked about the other data type like list. My list. Let me call it my list 1, if I like. You remember how we give a variable name anyway. My list 1 is equal to, now, a list, we use a square bracket for a list. Once you use a square bracket like this, that anything you put in it becomes a list. I hope you get the point. A string uses a quote, while a list uses a square bracket. Let me put some things in the list. I've gotten some names there. Let me say my list number 1, something on the list. The first thing on my list, I have Telis. Another thing I have on the list, I have another list, and I have LAN. Another thing I have on the list, I have place. And I've gotten
Yeah.
Adeiga, and I have another thing on the list. Barnabas, for example. Let's assume that these are the list we have, and these are the item I have in the list. So I've gotten, if I like, I want this to reflect a very good list variable name, I may say list of names. So list of names. And if I run it, it becomes a list. And if I want to check the type, I say type of list of name, list of capital O, capital name. If I run this one, rather. Class, we also talked about what can be in a list, and we're told that list may not only be a string, because in this list we have gotten a string. What about if you have another list? List 1 and is equals to 1, 4, 5, 7, 8, 10, 100. We say a list can contain either a string, it can contain either a number, it might even be, let me get another one, list 2 is equals to 1.3, 6.7, 8.9, 1.0. Oh, I did not put comma. So this is another list. 1.3, 6.7, 8.9, 1.0. This is a list of number. If I love, I can call it list of number of list of float. Let's call this list of float and call this list of integer. List of integer. We can also have list of Boolean, and this can be, of course, in a bool we can only have true or false. So we say true, false. So this is a list that contains true or false. And we can also have a list of mixture. So we are telling us here that list can contain, let me just call it mix, is equals to, it can contain anything. We can have a name like Ade. We can have a number like 21. We can have true. And we can have 22.8. Maybe there is a question that is asking us to talk about some property of someone. And this list has gotten the name of the person, like the name is Ade, and maybe the age is 21 years old. And we want to know if a question, something is true about the person or false. Maybe you say, is the person tall or not tall? You just say it's true, telling us that, oh, this is tall. So this is true. Or maybe another thing you want to talk about, the body mass index of such an individual, and you say the body mass index is 22.8. So this is a list that comprises different data type. All of these are lists. If you call type on any one of them, like we have called type on list of name, and we got list. If you call it on let's call it on another stuff. Let's call it on list end and see the list end. I just want to be copy and paste. I don't. So if we run this, it's still going to give us a list. If we check list of floats, for example, floats, let's put this. It's still going to tell us that this is a list. So this is a list, and if we continue like that, we'll get the list. List of mains, for example, list of bool, they are all going to be. It's not going to tell me that this is a boolean. It's going to tell me it's a list because we have declared it using angle and square bracket. Because of this bracket, we have gotten a list. Now let's talk about another data type we talked about in our last class. We talked about tuple. We talked about tuple. And in tuple, let me say my tuple. My tuple is equals to, in tuple, the difference between in our declaration, the difference in our declaration between a list and a tuple is the nature of the bracket we use. The same way we use list, we can also use tuple like that. So you can see this is not a square bracket, it's a round bracket. So if I put it in a round bracket and I run it, the only difference now is just like the former one, the list of names here we have in the square bracket, while this one is not in the square bracket, is in the round bracket, right? The normal bracket everybody knows as bracket, so is in a round bracket. If I run this, the type will tell me the type of my tuple, yeah, will tell me that the type of my tuple is a tuple. It's not a list. Of course, there are differences between list and tuple in operation. That is not what we want to go into for now. So, but naturally, if you love, you can declare your data as a tuple. If you like, you can declare it as a list. Just the only difference is just the nature of the bracket you use. Another one we talked about is a set. Set, let me say my set is equals to, now in previously, before I continue, previously we have used this to denote something. We have used this. Please, everybody, you have to unmute yourself and speak up. We have used this. Then we have used this. Please quickly unmute yourself and let's speak together here. Please unmute yourself, everyone.
Yeah.
Yeah. So please, the first one, what do we call the first one? Once you use that to declare any data type,
String.
What do we call this? Once we use this to declare a data type, that is what?
String.
A string.
Okay. So when we use the second one, it's also a what?
String.
A string.
So when we use square bracket, it becomes a what?
A
List.
list.
And we use round bracket, we have what?
Tuple.
Good. Now, the next one we want to talk about is another bracket we will call the curly bracket. in mathematics, you know, when you talk about sets in mathematics, you say the set of a number, there's maybe A is a set of a prime number and between 1 to 10, and you are asked to list to put the prime number or maybe to do some set on it. So if we want to assume that now, like we are having a set, we use a curly bracket. Let me bring this one up here. So we are going to be using curly brackets for a set, and we say, for example, we want to say, this my set is a set of, okay, let me just say my prime. My prime. So say this is a prime number between 1 and 10. So which we start is going to start from 2, the next one is going to be 3, then the next one is going to be 5. The next one is going to be 7. So these are the prime number between 1 and 10. If this were to be a set of number between 1 and 10, this is not a list. This is a set. If I put it the other way around and I come and say Ctrl C, let me copy and paste. I put this. Now, this my prime, the first my prime is a set of number between 1 and 10, maybe a prime number. Then the other one is not a set, it's a list of number between 1 and 10. So let's try another one. If I put this is going to be a tuple of number of prime number between 1 and 10. So you know the difference between set, tuple, and we have set, we have list, and we have tuple. Is that clear? So we only want to quickly remind ourselves of what a set looks like. So this is what we call a set. So if I run this and I call the type on it, I say type of my prime, and I run it, it's going to tell me, oh, this is a set. It's not a tuple, it's not a list, it's not a string, it's not a bool, it's a set. And you know, the other operation, every operation that can be performed on set, if I have like 2 of them now, I can perform set operation like union, intersection, and prime, like every other operation that can be done on set can be done here, since this one has been declared as a set. So these are the data type. There is a data type not mentioned in our last class. Yeah, that is none. None is a data type. We did not talk about none. And meanwhile, we're going to be using none very much as a data science or a data scientist or an analyst. You will be coming across a different type of none. For example, if I say name 1, and I say it's equals to none. So none is a data type that is nothing. It's none. There is nothing in it. Like, for example, I give a form. I say everybody fill this form, and there is a particular field in the form that somebody decided not to fill. We're definitely going to be a none, because it's not going to be list, it's not going to be a string. We could have an empty string, we could have an empty list, we could have empty of all these other data types, but empty is not the same thing as none. It's empty, you decided not to put anything, and it's an empty list. But a none is a data type that will definitely tell you that, oh, nothing that is inside my name. Let's see, type. You will see the use cases when we get to Pandas. So none type, because this is a none. Let's try to print. Let's try to print that out and see what we're gonna get. So let's say print. What are we printing? Name 1. Let's print it and see what we're gonna get. You can see it's none. we are not going to get anything. That is none. So it has a place, and there is a way we deal with all this non-data type, and as a data science or an analyst. So when we get to Pandas, or DataFrame, we definitely going to be coming across a lot of none that will be a disturbance in our data type, in our data, that we have to remove them. Sometimes we have to replace them. There are so many things we can do with them. So we're definitely going to come to that. So far, these are the different data types we discussed. And now let's share the slide again and see what we have in the slide. Please, can you confirm you have this with you?
Yeah.
The building functions, right?
Yes.
Yeah. So we talked about the building functions. Sometimes we already talking about some of them. We're already using some of them, but we don't even know where they come from. You can see me saying type, brackets, a particular data type, and it's going to print out the type of that data type. These are building functions in Python. They are there for you to use. You just use them. Once you write print, Python already understands what the print means. Once you write length, Python understands what you mean by the length. Once you write input, Python already understands what you mean by input. When you say type, of course, we have used type. And when you talk about range, Python understands what you mean by range. So let's quickly over. All these are data types that we can easily talk about. Let's see how we can use some of them. Let's quickly use some of them. Let me copy and let's share them in our coming. Sorry, I just want to copy and put in the Jupyter notebook so that we can look into them one after the other. So I want to be back to my Jupyter notebook, please. Can you confirm you see this Jupyter notebook?
Yeah.
Okay. Now, these are some of the functions we want to talk about. Can you see it? Can you see it?
Yep. Yep.
So we take some of these functions and talked about them, how we use them. We'll be using a lot of these functions in our as we go along in this course. Now, the print function, we already know how to use the print function. If you want to print any of these, our data type out. For example, I declare something as hello world here. Let me create another empty space under it. So if I want to print, I already have my variable, which I say hello world. If I want to print it out, I say print, I put it in a round bracket, print. I'm not going to say print hello world. I want to print the variable, print my variable, which we definitely print hello world, because what we have gotten inside the variable is hello world. So if I say print my variable, we get hello world. At the same time, you can as well come and say print. Instead of putting the variable there, you can easily print, let me print something and say kudos. Okay, happy to be here. I hope you are. So I'm happy to be here. I hope you are. So I want to print this out. I just put it in the print. But you remember that because it's a string, I put it in the quotes. I should have used either a single quote or double quote. So if I run this, it's going to tell me that hello hello to, okay, happy to be here. So that is what print does. Happy to be here. I hope you are. That is the function of the print. Either you print a variable. If I can print ordinary number, I can just say print. You know, in the case of number, I'm not going to put it in anything, except I want to, okay, I can just say print 45. When I print it, it's going to print 45 for me. Yeah, you can see print 45. Let me make empty space. I still want to print. I say print. I can still perform some operation in it. I say print 20 plus 79. I can perform operation inside the print. So which would definitely, that is 99. These are one or two things you can do with your print function, though. You're going to be using some of these print functions as we go along. So another one we want to talk about is length. Length. This is a length. When you talk about length, you want to know how long is a particular, maybe you have a word. You want to know how long is the word. For example, you say come. You say, what is the length of come? You are asking like, how many alphabets do we have in it? So definitely we're going to give me like 4 or 5, depending if you put space. So the length, return the length of an object. For example, the number of elements in a list, the number of character in a string. Sorry, coming. The number of character in a string etc. So if I want to know, for example, here I have hello world. Let me create an empty space. I want to know how many digits did I have here, or how many. Of course, immediately you put a what do you call it? A space. A space is also going to be counted. So if I put a space, if I remove the space, let me put it together and rerun. So it's going to be how many words did I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I say length, the length of my variable, if I run it, it's going to tell me it's 10. You can see that is how to use length. So when you see a length, it's just trying to count whatever you have in it. And once you put a space and you run it, if you rerun this will tell me it's 11 because the space is going to be counted. That is 11. That is the function of the length. So even in let's use it for something like list. I have a list here. If you have a list, this is a list. And we want to check the length. Let's see. Let me curate a space. I want to check the length of what I have inside this list. List of names. How many things did I have there? 1, 2, 3, 4, 5. I have 5 items there. So I can just say length. Oh, length of this list. If I run it, it will be telling me that the length of this, I have 5 items there. This is the length. I know at this point you are tempted to say, okay, what about if I want to know the length of Felix? I want to know the length of Lan. I want to know the length of Blaze. That one you have to run some conditional statements to check each item in the list of name. For example, we are still going there, but let me just tell you what I'm talking about. I know this is a list. The length of this list is just 5. If I check the length of this, it will be 1, 2, 3, 4, 5, 6, 7. If I say length of list integer, this one. If I check the length of this, it will tell me that the length of this one is 7 because I've gotten 7 items there. But let's go back to the length of my name. there's something I want to point out, because someone will be tempted to say, what about if I want to know the length of Felix, the length of land, the length of Blaze, the length of Adeyiga, the length of Barnabas? If I want to check, how am I going to check? This we have to use control flow. For example, I say for I10 or items in list of names. For items in list of names, what should you do to those items? Maybe I can say, for every item, if you're going to check the list and pick the item one after the other, the first item that will be picked is going to be Felix, followed by land, followed by like that. What should happen to them? For every item in this list, get the length of the item. I can just say length, or I can even say print. To just print item, the item, to print the item itself. Items, rather, to print those items with, after printing the item, to just print maybe empty space or, and the length. Let me put empty space so that it won't just join together. There should be empty space. Then after printing the item, you also print the length of the item. Length of the items. Those items. So if I use items without S, I should refer back to the items without S. So, or S, it should not run. Let me run it and see. Oh, there is an error. Let's see. What's the errors all about? Int to string. What? For items in list of names, okay, print items plus a space plus the length of the items. So what is the error all about? Number 2, can only concatenate. Okay, yeah. Because let me put this. Let me run this first, and then we'll go back to it. There's going to be can only concatenate string. Oh, item is a string. The length is okay. Let me put string here. Sorry. This thing I'm doing, you will soon understand, because we are going to get to list conversion, STR. Okay, now that is a string, let me put empty space. Sorry, I will explain what happens to you. There are 2 different things that we are putting together, and okay, you can see what happened here is like if I just check the list, the length of list of names, which I did, is 5. I have 5 items there. 1, 2, 3, 4, 5. But if I want to check the length of every item, the items there, I want to check the length of them, I will use a loop. I will use a for loop. I say for items, all these items in this list, that is list of names, what should happen? Take the item, for example, take Felice, this is it. Put a space, that is this space, then put the length of that item, that is Felix. So it's telling us that the number of the length of Felix is 5, the length of land is 3, the length of Blaze is 6, the length of Adeyiga is 7, and the length of Barnabas is 8. This is how to use length. But don't worry yourself about the for loop. It's part of what we are supposed to do today. Just calm down. We're going to talk about the for loop. We're going to talk about the if loop, if else, and then if, early, if. So those are things we're gonna talk about today by God's grace. So we have talked about the length. Oh, now before I go, I was having a problem here before I put this list. If you check this item from the list I have here, it's a string, because it's going to say string, Felix. Now, I now want to add it to the length of an item, which is not a string, which is a number 5. You cannot add integer to a string. If you want to do that, the best thing to do is to first convert that integer back to string. Then you can now add them together. If you can either add a string to string, integer to integer. So if one is integer and the other one is a string, all you have to do is to convert one to another before you can add them. So we are going to call that one casting. So we talk about casting as well as we go on. Now, another, we've talked about print, we've talked about length. There is an input. Yeah, if input is, I know many will have been thinking like, if I want to write something myself, I don't want someone to put the name for me. I want to put the name for myself. For example, I say name. I want to collect the name of everyone on this lecture, and I say input your name. I say name, for example, is equal to input. I don't want to write it for you. Input. Oh, sorry. What's wrong with me? Input. So, and I pass this one to everyone. I say type your name. Type your name in this space. So when I say type your name in this space, if I run it and you come, you're gonna put your name, but I want it to, okay, let me just follow through one. I say type in your name, I run it. So you can see it's prompting me to say, okay, type in your name. If I want to type my name, I say Abdul. Abdul Wasil, for example, and I run it. Immediately I'm done. I press enter. That is my name. So I've already typed my name. If okay, Abdul Wasil. So I type my name, and if I come here and say name, and I run the name, maybe I say print name. But what's wrong? My print is print. Okay, I use capital letter to call print. Print name. So I have print name here. Oh, I put name 1. And if I run this print name, it's going to bring out Abdul Wasil. That's one. And someone would think, what about if I have a lot of this name and I want to collect everybody's name? What I will just come back here. The only thing I will do, maybe perhaps I put this in a loop. There are so many things I can use. I could say, okay, let's assume we have like about 10 names. 10 names I want to collect. The first thing I can say, name. I put it as an empty list. As an empty list, maybe I say name, the names, the names of everyone. So is equals to empty list. So the name of everyone here is equal to empty list. There is no name yet. If it's just an empty list and I want to take 10 names and I say, okay, let's start a count. I say count. Maybe I say number of name to put, maybe is equals to 10. I want to put 10 names. And I want to start count. I say count is equals to 0. If I put the fourth one, my count is going to be incremented to 1. If I put the second one, my count is going to be incremented to 2. So once the count is up to 10, then it's going to stop. It's going to stop asking you to put your name. I will now say, I can use follow or I use if. If count, which is 0, count is less than number. of course, the number we are talking about is 10, or we can even just say it's less than 10. What should happen? It should continue asking you to put name, be asking them to put their name. So if count is less than 10 or it's less than number, of course this becomes redundant. Let me just remove it and just say it's less than 10 straight. Since it's less than 10, I'm looking for 10 names. Now, this should be asking everyone. Once the first person enter and say, this is my name, you should ask again. Enter your name, ask again. But once it's up to 10, it's going to stop. So, and be putting them inside these names of everyone. Once the first person puts the name, we now say, okay, if you put your name, what you should do, append that name. Say name of everyone, dot append. Please, all this thing we are doing, we get to append and everything. I'm just trying to write some code so that you understand where we are going. Name of everyone dot append. It should now be appending the name you enter, dot name. So once you put your name, it's going to append it and put it name inside the empty list. It's going to append again and put it inside the empty list. Then after that, the count, which is 0 initially, this thing was checking count, will be incremented to maybe the next one will be 1. So the count, maybe we now say count plus plus. The next count is going to be count plus plus. So the next one is going to be 2. The next one is going to be 3. The next one is going to be 4. So this count will keep updating. This count will keep updating because the first one is a 0. After you run the first one and put the name, the count should no more be 0. So the count should now be 1. Once the second person puts the name and run it, the next one, the count should go to 2. The next one should go to 3 until we get to 10 when this is going to stop. So let me run this. So, okay, count plus plus, what's its count? Okay, let me say plus plus count. Anyone? Of course, there is a difference between them. Let me see. Let me run. So if I put the first person and I say the first person's name is Abdul, immediately I enter, it will not go and print anything. It will ask for another name. Put Abdul, run. Okay, I'm not using Y. Why count? Let me use count. Why? Because it should be a continuous one. Why? Sorry. Because I want it to be a continuous one. Why count it? Let me see, Abdul. So it will ask for another name. John or John. Another one. Okay. Another person. Lay. Another one. Another one until I get to another one. And it's going to stop when it gets to 10. Another one. Another one. Another one. It's not up to 10. No, what happened? 1, 2, 3, 4. Why count is less than 10? What should happen? Name should be this. Name of everyone should append this. Then this should be plus plus. Okay, let me rearrange this. It means my count becomes, this is where the problem is. Plus is to count, please. Yeah, that is where the problem comes from. Let me rerun again. Okay, let me rerun again. Okay, Abdul, next. It's going to put, when it's up to 10, it should stop. Oh. What is wrong? Something is wrong here. Okay. Oh. You can say, as I'm typing, I'm having problem with this, my count. Please, just bear with me. That is the problem we face when we code. You always have some errors that you have to look for a way of fixing them. Abdul, enter, then another one, enter, another one, enter, another one, enter, another one, enter. But why? It's not stopping. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, no. Something is wrong here. I don't know. Maybe we just got to leave this and come back to it after we have done Y. What we are doing, we say from, oh, we have gotten a lot of errors here. Oh. I don't know when this one came to it. We say we have names of everyone is equal to empty list. We say we have a count is equal to 0. Why the count is less than 0? What should happen? Should keep doing this. Let me put it to 5 so that, or let me just put it to 3. I think we can, we are testing something, so we should start from something that is not far. I don't know where the other one came. What's happening? Why count is less than 3? Why count is less than 3? We have a name should be this, and then the name of everyone should be appended in that my name. And when the count is just up to 3, that thing should stop. I don't know what happens. Okay, not to waste our time, we come back to that. We still have it under, let me just print names and see. Something is wrong here. I don't know. Let me delete let me just delete it and start afresh. Yeah. Name is equals to empty list. There is nothing inside our name. And what we want to do is that we want to put a name inside it. We can say append if we have a count. Let's have a count. If count is equals to 0, for example, and if a condition, that is the count is less than 5, for example, or it's less than 3, happen. What should happen to be, we should have a name, your name, to be equals to input. Input, what are you inputting? Input your name. Enter your name. So once you enter the name, you should check a condition like count. The new count should now be equals to, let me, okay, the count is correct. Count should now be equals to, you had a count plus 1, let's say plus 1, it count. So if you had that, after you had your count is equal to 1, then you append, even before then, you append name, you append dot append, you append what you have as your name. So let's see. So if I say Abdul, sorry, everyone, we are going to encounter a lot of once we are coding. Sometimes it's just going to even be a comma that you miss, and then you keep looking at where is the problem coming from. Abdul, you enter. So no, the if is not rolling. Let's leave this. When we get there, we run that. We go back to it. So not to waste our time. Now let's go to. We have checked. We have been able to check the length, the function of the length. We have checked the function of the input. We have checked the function of the type. Everybody knows what we use type for now, right? Please unmute yourself and talk.
Yep.
Yeah, you know what you use type for. Then the range, we also say range is just like a another data type, which we talked about last week. For example, we say range. We say range, you can say range 6. We are saying a number between 0 and 6, rather. So if we want to print a number between 0 and 6, we can say for number in range 6. For example, I can say just print this number, print the number between this range 6. Let's just say number. Just print the number for me. So it's going to start from 1, 0, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. That is the function of the range. If you say range 100, it's going to print a number between 0 to 99. So to 99, oh, I put 10. If I put 100, just going to print a number between 0 and 99. You can see to 99. So it has its own function. So we definitely talked about them when we got there as well. This is how to use a range. And at the same time, there is a way you can use a range and indicate the step or where to even start from. Let's see. Let me say a number starting from 50 to 100. Let me run this and see. So you start from 50 and you go to 100. It's not starting from 0 again. Let me say from 50 to 60. To 60. If I run this, it's going to start a number from 50 and go to 60. I hope you understand how to use the range now. So it generates a range of number. And I think you can also put some steps and say, okay, 50, maybe print it like 2 steps, like 50, 52, let's see. I think it has a step you can put. Yeah, 50, 52, 53, 50, and 50, 52, 54. If I put it in range 3, for example, it's going to be 50, 53, 56, and increment. Assuming I want to print an odd number between 10 and 1 to 10. 1 to 10. I want to print a odd number between 1 to 10. Odd number. So let me print in range 2. So it's going to start from 1. Range 2, is it going to give me an odd number? Let me see. Yeah, odd number. Yeah, in range 2. That is 1. The next 2, 3. The next 2, 5. The next 2. In programming, there are some things to think about. If they are not correct, then you just change some of these parameters. For example, if I think of range 2 the other time and it's not working well, I might decide to change it to range 1. Of course, range 1 is going to be everything. So range 3 is going to be 1 plus 3. That is going to be 4 plus another 1. So it's going to print 1, 4, 7 instead. That is how to use a range. We also have which other one? We talked about range. Now we talked about in the other time we talked about when I was trying to convert string to a number or a number to a string somewhere here. Yeah, somewhere here. I was trying to add number to an integer, and I was trying to add an integer to a string, and it was giving me an error. It will never work. you cannot add a number to an integer, a number to a string rather. All you can do, the first thing you can do before you can do that, you have to convert one to the other. This is what we call casting. So, and we have gotten a lot of ways to do that, and these are the method, these are the functions we call here, these functions. We say int, float, string, list, tuple, list, and set. Let's copy them and see how to use them. Don't forget, we have work that's an abandoned work here, and we are going to do it later when we get to float today. Is quite unfortunate, I don't know. We are going to do its name and stuff like that. Those are going to be what we do when we get there. But let's quickly talk about this. I have it's easier for me to say an integer. I have an integer, for example, variable integer int1 is equals to 35. I have variable variable float1, for example, and I say is equal to 8.5, and I come and say variable integer, okay, maybe I've used one, okay, I've used integer, variable string, let me call it string1, and I call it come, for example, or go. Let me just use go. Please, everybody, are you with me? Unmute yourself and speak.
Yes.
Yes.
Yeah. So these are variables we have here. Now we want to perform some mathematical operation on them. It's easier for me to come here and say variable integer plus variable int1 plus, for example, I want to add it to variable float. Float1. Please, what did you think the output should be? What did you think the output is going to be? Maybe I should store it in variable sum is equal to, please, what did you think the variable sum is going to be? What should be the output?
43.5.
That is 35 plus 8.5, right?
Yeah.
And we think it's going to be what? 33.5, right? Now, if it's giving us 33.5, what we are saying is that we are adding integer to a float, and there will be no problem. We can add it. But this one will automatically be declared a float because we are going to get a decimal place. This, there are some conversions that are automatic between float and integer. Anytime you do integer have anything to do with float, it's going to convert everything to float. So if I run this and I have for the type of my, let me just run. I've run it. What happened? Okay, I've not run this before. Name variables. Which variable? Okay, float is not defined. Oh, sorry. Float1. Variable float1. Then, okay, let me see. Maybe I've not run it before. Let me rerun it. The name floats. Okay, variable. I use capital V. Capital V. Let me run it. Now it's running. So I've been able to run, but there is no output. I don't have an output. Now, if I want to know the type of my variable, type of verb sum, the type of verb sum should definitely be a float because I have added an integer to a float. So it should automatically convert everything to float. Now, if I want to get the output, I just say print. Just print the sum for me. Verb sum. Just print that for me. So if I want to print it, it will bring out the float value, 43.5. I hope you get that right. Please,
Yep.
Are you with me?
Yep.
Between integer and variable, if you want to do any operation, you don't need to convert anything to anyone. You don't begin to think like, let me first convert the integer to float, or let me convert the float to integer. Let me convert this to that. No, you don't need to do that. You don't need to do that here. But when it comes to string and integer or string and float, you cannot add them together, or you cannot multiply them. You can't multiply them or add them together. For example, if I want to add string one, a variable string one, let me say sum2, variable sum2 is equals to, I want to add variable string one, right? So plus I want to add it to any one of them. Let me say variable integer, variable int1, int1. So I want to add the two together. What I'm adding is go plus 35. So maybe it's just going to be go 35, right? So if I run it, it's going to give me a problem. There is an error. And the error will tell you that, you can see, can only concatenate string, not into string. You can only concatenate string to string. You cannot concatenate string to integer. So once you have something like this, you have to do what we call casting. And in casting, what we use all these for casting. We use them for casting. And how do we do that? To convert from one, maybe one data type to another. So all I will do, I will come here, and this string, I have a string and I have an integer. This integer, I can turn it to a string to be able to perform the operation. What I will do, I've just put it in a bracket and I put string outside it, str. That will automatically convert it to string. And this is how to do it. You want to convert something to integer, you put int and you put that inside the integer. You want to convert something to float, you put it inside the float. You want to convert something to string, you want to convert to list and dictionary, etc. This is how to do them. So now that I've added a string to it, it means I'm adding a string to string. So if I run it now, it should run. Then if I want to check the output, I should get some output. I don't know what the output will look like. So let's see. Maybe it's going to say 50, 20. I don't know. Maybe it's going to say go, let's see. Go what? Go 35. Let's see what the output will be. I don't know. Let's say print var sum2. Yeah. So print it. So it's go 35. It has been added. Go 35, which go 35 is now a string. So this is how to do casting. That is how to convert from one. You use these functions to convert from one data type to another. Let's still try to see some other data type. For example, I have this data type. Yeah, let's copy some of our data type. This is a tuple. There are some conversion that is not gonna make sense. It's not going to make sense for you to say you want to convert a tuple to an integer. It's not gonna make sense to say you want to convert a list to an integer. But it's going to make sense to say converting a tuple to an a list. Of course, the only difference between them is just a bracket. So if I have this my tuple, we have it initially. I want to convert it to list. I can just say list. List my tuple. Maybe I should call it another thing. Maybe I should store it in. Maybe I should store it and say my tuple convert. Okay, let me just put, since I'm using convert. I want to convert it. I just say convert this tuple. I say list convert my tuple. So this my tuple is a tuple here, because if I come here and I run it, for example, I just say print my tuple. It's going to print a tuple for me. You can see it's a tuple. of Barnabas, and you say it's a tuple. If I call on the type, it's still going to be a tuple. But I don't want it to be a tuple. I want to convert it to list. If I run it, so it has been run. If I go and print this one, it's no more going to print it as a tuple. It's going to print it as a print. It's going to print it as a list. So you can see the difference between the two. This has been converted to list. This has been converted. So the same thing, you can convert your integer to a float if you want. For example, if I have an integer, int float, for example, is equals to, okay, maybe I just have integer variable is equals to maybe 23, for example. And if I have this and I run it, if I print this out, if I print it, it's going to give me 35. But I can turn it to integer, I can turn it to float just by putting float at the back of this, converting it to float. So it has been converted to float. I don't want to store it, I just want to print it directly. If I run it, it's going to give me 3 points, you can see 23.0, which is now a float. That is how to convert. Those are 1 or 2 ways to do this conversion. And some other, please, let's quickly run through. The time is going. Let's pause the sharing and run over some of these. Please, can you see all this? Please confirm you can see my slide. Can you see?
Yes.
So these are inbuilt functions. I don't want to run through all. We are not going to have the time. So the same thing, you can do oval, you can do format, you can do sum. There is maximum. If you have numbers, you want to check the one that has the maximum number and the minimum number, you can run maximum, you can run minimum, you can run. With time, we'll be coming across some of these things. But these are the inbuilt functions in Python. And building functions. We have enumerate, we have save. We're going to come across some of these in list. So just have an idea of, like, we have some of these functions that are in Python that we can use. Example, we have when we are given our definition, we're talking about iteratables. You will see, like, some of the functions says return an iteratables. Or you come across iteratables. Anytime you see anything iteratables, sequence, this is what we'll refer to. Example of iteratables, they are list, they are iteratables. What we mean is that we can run some for loop over there. So that is where we want to go. So I want to run fast so that we can quickly get there. Our time is going. Example of iteratables, we have list. It's an iteratable, tuple, string, set, dictionary, range. Of course, you can see the other time we run about it and we talked about range. All these are iteratables.
Hi, Abdul.
Type conversion, we call casting. We've talked about that, how to do type conversion. Type conversion refers to the process of converting one data type into another, which we have done. We have been able to convert list to tuple or tuple to list. We've been able to convert floats to integer to string, and things like that. This is what we call casting.
Sorry, we are not seeing your slides. We're seeing but the Google Colab.
Oh, I mean,
Yeah, that's fine.
okay, you can see this now, right?
Yes.
Yeah. So we talked about how to do the conversion, and this conversion is what we call casting. We have demonstrated that. So, for example, we can use int, convert a value to an integer, float, which we have demonstrated. And we talked about something that we automatically convert, which we call an implicit type conversion. For example, when you had a list to, when you had an integer to a float, the output automatically becomes a float. That is an implicit data type. That one, Python will know that this is a float and an integer. Please convert it directly to a float. So Python will do that for you. But the one you have to do for yourself, you have to use these keywords. You have to use them. You have to use all these functions rather to convert them. We've seen more examples like list and etc. Random numbers. We have to quickly talk about random number, for example. We have what we call a random number. You can generate random numbers. Oh, I cannot copy it. Okay, I can copy now. Yes, let's go generate this random number in our Google Colab. Please, are you with me?
Yep.
Can you confirm the Google Colab?
Yes, it
Yeah.
works.
Okay. Now we have generated a random number before. Can you remember that random number? Something that looked like the random number. Range. You can remember range. We have used the range before, where we say, let's generate a number between 10 to 100 and some instead, right? And we use 4 for the range, for I in range, call it anything, for I in range 15. If I do like this and I say print I, it's going to print I. So if I run it, it's going to run 0 to, oh, what happened? Okay, I not put there's so it's going to run from 0 to 14, right? You can remember this.
Yes.
Hello? Yeah. So, and we also even say we can start from somewhere. If we want to start from 9, we do like this and we run it again, it's going to start from 9. You can see. We can even say, okay, let's put it in the step of 2 and say, okay, every 2, 2. So if you print 9, print 11, you put 2 instead and you run. So 9, 11, 15. That is a range. Apart from that, we can generate other random numbers. And you import, there are some, we have what we call libraries in Python. Some of this library, one of the libraries that we can use is random. So you import something from random. You import, let's just import random rather. So if I import random, if you don't import random, there is no way you can use the random function. So you have to import it, the libraries. So in data science or in data science or analytics, we have some of these libraries that we use. We'll also be importing them, things like NumPy, Pandas, Matplotlib. So just be used to this keyword and imports. We're going to be using it a lot. So you have to import random. So when we import random, it's the libraries are being imported. Then this is one of the things I want us to do. I just want to print out a random number. A random number in the range of from 1 to, let's first do this without putting 2. Print. So it's going to print a random number between 1 to 10. Any random number. If I rerun it again, you know, it's not going to print the same thing. It's still going to print another one. Let me rerun. You can see 8. If I rerun it again, it might decide to print 1. You can see. So please, everybody, unmute yourself here and let's quickly talk about the practical implication of this. Please, everyone. Everyone, please, let's unmute ourselves. Please, everyone. Please, Prince, Ogun.
Yep.
Please, let's all unmute ourselves. I want us to talk here.
Yep. Hearing you.
Okay. Now, if I want to run I want someone, there is a number between 1 to 10, and I will call us one after the other. Prince, are you there?
Yes.
Hello, Prince.
Yes.
Please guess a number between 1 to 10 and tell us.
Okay. Oh, I tell you, 7.
7. So if I run it and you are not getting 7, it means you lose.
Hey.
So, oh, 7, you won. Right?
Okay.
You can see it's like a game.
Yes.
If now I now say, let me call someone, Lewis, please guess a number. It's not there. Messi, guess a number. Guess a number.
3.
What?
3. Number 3.
3. Okay, number 3. Okay, let's see. If I run it and we are not getting number 3, it means you. Oh, 3. Why? Everyone. Okay, another person. Let's call for another person now. Anyone, please guess a number. And please just guess a number.
8.
5.
8. Oh, 8. You lost. Another person. We have what?
5.
5. Let's run it. 8. You lost. That is 9. So we can actually use this to build a game where I will say input a number. So if the number you enter is equals to this, then you won. So let's quickly let me run a program for that. Yeah. For example, I say okay, this I want to give it to let me call it gas. Let me just call it gas and see if this is my gas. I want to make some gas. Yeah.
I don't be window no. So how's it go then?
If this is a guess I want to make, and I say this is my guess, and I now want to prompt someone to input something, and I say input. Okay, maybe make a guess.
T-shirt, man. What? Where hood?
Is equals to input your number. Input a number between 1 and 10. I say input number between 1 to 10. So of course, this we always give a string. So because it's always given a string, we love to put it in since it's a number we want, we put integer at the back. This is casting. I want to cast it. Now, I now want to set a condition like if guess is equals to the guess you make a guess. Make a guess. If guess is equals to this, then if guess is equal to that, what will happen? You say print. Just print and tell us you won. Okay, I have to put it in you won. Let me put exclamation, you won. S. If you didn't win, then S. What will happen? You lose or try again. Print. Try again. Try again. So this is it. Before then, let me print something. Print guess. And also Please, are you with me? So I want to see the guess you make, and at the same time, before I tell you try again, I want to see the two. Please, are you with me? So this is a small program that I want to use to see if someone make a good guess. So I want to make a guess. Input a number between 1 to 10. Please, someone should make a number, should tell us a number. Please.
6.
6. Oh, what happened? Unsupported operand, this for, okay, it's still the same casting. There's a problem here. Int and string. Unsupported operand type X for plus. Okay. Let me just make a space if this is not coming out well. Yes. Okay. You know, the problem is that I'm just done with some okay, what happened? With some JavaScript code, so it's having great impact on my coding these days because I've been doing a lot of JavaScript coding. Okay, let me just say print guess. Let me print it separately so that I won't disturb myself. I'm just done with some, I'm doing some Java coding these days, more than Python. So that has been interfering with my Python code. You know, sometimes you print, you do coding in one language and you do in another language, then it becomes a problem for you sometimes. You will forget and be doing some other language in another one, and that will definitely impact whatsoever the output should be. Let me just, so I don't want to, okay. So somebody said 6, right? So try again. Inputs, it means the number the number that was generated, we have 2. The number generated is 2, while the number you input is 6. So it's not the same. So you try again. Let's run again. Let's make it get 6 again and see if we're going to be fortunate this time around. Oh, try again. We have 1. So let's try 6 again and see. 6.
3.
Oh, it's not fortunate. Somebody, you said what?
3.
Okay, someone said we should try 3. Let's see if we are going to win. Oh, 8 instead of 3. We have 8. Okay, another guess. Make another guess.
9.
9. Oh, let's see. Oh, you won.
Wow.
You can see. So you can keep generating that and ask someone to play some games. And so this is the beauty of some of these random number. You generate random number from range. Imagine we put 20 here. We're going to have a lot of problem here. Imagine, just say 1 to 20. Can decide to say 18, and at the point it goes to, okay, let's run that again. Let me put 13 and run. Oh, this is giving me 2. Why I put 13? Let me run again. Let me put 12 and run. Oh, 9. Let me run again. Let me put 19 and run. Oh, 9 instead of 19. You can see someone can keep playing this. Imagine someone is paying for playing this type of game. You give me £5. So when you lose again, you give £5. So if you win, you give £10. Maybe you collect £10. So that can be a game. So it can be a game. So this is one of the usefulness of using a random number. And the random number we have used so far, let's check the other one. We can use run in. We can as well use can you see my screen? Can you see this? Hello?
Yes.
Hello, everyone. So let's try to run int 1 to 100. Let's do 1 to 10 rather. 100 is, let's see. So it's a random number, just the way we have a rand range. We also have rand int. And if we need a random number between 0 and 1, so we're not going to use either of the two. We use this one. We use random.random. We'll be giving you a random number between 0 and 1. 0 and 1, like 0.1, 0.5, 0. Stuff like that, and maybe to a particular decimal place. So if you run these, we're going to be getting a random number. You can see 0.88, 0. If I run it again, I get another random number, 0.49, 0.46. If I run this again, but it's definitely going to be between 0 and 1. So that is what this function performs. So we're talking about the built-in functions, inbuilt function. And we've been able to talk about random number as well. We talked about range. So let's quickly go back to our slide. Are you with me? Can you see this slide?
Yes.
Now,
Yes.
so we talked about the range as well. We know how to use the range. When you use the range, you use 1 to 6. It's going to print from 1 to 5. And when you put some step in step 2, in step that, so that is how to run range. Identifier. We talked about identifier last week. Identifiers in programming are names given to a various element. You can see we have been putting these our data type in a name. Sometimes you say, let's call this name a variable 1. Let's call it variable int. Let's call it that. These are identifiers. And the way we've gotten some rules for naming identifiers. Identifier can start with a digit. We discussed that earlier. Identifier can start cannot contain special characters like at. The only character that identifier can contain is underscore. You cannot put $sign, put a percentage in the name of any stuff you want to put as an identifier. An example of identifier is a variable name. So you cannot put that. An identifier at the same time cannot contain a keyword. We have what we call a keyword in Python. I think the keyword is about 45. You see this list of keywords. So we can use this one to import the keyword. We can use this to import all the keywords in Python. Let's see. Let's go back to our collab and see this. Let's stop and share another one. The collab. So your identifier or your variable name cannot contain what do you call it? Keywords. So these are the keywords in Python. You have to import keywords before you can print them. So when you run it, so these are the keywords in Python. You have false, none, true, and. So you don't just come and say you want to give a name to any variable, and you come, for example, and you say the name of the variable is. You put that the list there. So no, you don't do that. So if I want to run a variable and I come and say yield, for example, is equals to hello world. If I run this is going to be an error because I'm using a reserved word. So you can see yield is pointing to yield. Assignment to yield expression not possible because it's a variable, is a reserved word. Is a keyword, or you call them reserved word. You can use them as a variable name. But if I want to use yield, I can just manipulate. Maybe I put my yield, my yield. Then this becomes a good name now. It's no more yield. So maybe I can put, I can use snake case. Of course, you are taught how to, okay, my yield. If I run it, it's going to run because it's no more a reserved word. So these are the reserved words we have in Python. False, none, true, and, asserts, await, break, etc. like that. They are reserved words. How many of these reserved words do we have? How can we get it? How can we know the total number? If we run length on the reserved word, maybe you just say length. You want to know the length of the reserved word, or in fact, if you like, you can put it as a list as well. If I want to put it as a list, I can just copy the reserved word and list it as a list. I want to put it as a list. And I run it if we convert it to list. Okay, maybe, okay, it was already list, I don't know. It was already in a list form. It's a list now. So if I want to run again, I can come and say, I want to know the length. The length of my reserved word. I can say length. If I run it, it will tell me the length of the reserved word. So it means in Python, we have gotten 35 reserved words that cannot be used as a variable name. These are the reserved words that we use in Python. Lambda, in, is, if, global, finally, those are the reserved words we use. Now let's go back to our slide. So we have talked about the variable, and we gave the name, the way to name the variables, the camel case and the snake case. You can still remember that. So now we are here to talk about comments. There is a way we comment in Python. You can use a single comment or a multiple line comment. So let me quickly run that because of our time. This time is going. I don't know. There's a lot we want to do, but I don't know how we're gonna manipulate our time.
Hey guys, let me just jump in. So yeah, how many people can show a hand if they want to carry on beyond 12 o'clock? Or to let us know, say yes.
Yes, from me.
Oh, I've got a jet. I've got to leave real quick. Yeah.
Okay. So Samand, yes. And
Yeah.
also, yeah.
But it depends on how much time we're spending for.
Oh, just to extend a bit to cover a little more, so that next week.
What 12:30? Do you think is a good? So do you want to know it's like 12:30? Would that be?
Let's just say like 12:30.
12:30.
Yeah.
That's fine.
Yeah. Okay. Cool. Okay, guys. Let's carry on then. Let's carry on.
Okay. Let's quickly run the okay, is it the code we are running now? Where do we stop?
If anyone has got to leave at 12 o'clock, that's absolutely fine. The excuse me, the recording will be up on the BDPN website Tuesday, Wednesday at the latest. If you want to watch anything back, I'm going to also email you all over a link for a survey we're doing regarding talent, black talent, getting jobs, getting further in the recruitment process. And we need everyone to kind of fill this survey in to help not just you, but the wider black community in being successful in getting vacancies, getting employment. So we'll also share that link in an email to you all at the early part of the week. And I need to duck out of this. So I want to say thank you, all of you again. Thanks to Abdul, and I will see you all next week. Thank you.
Thanks. See you, Ian. See you, Abdul.
Hello, everyone. Yeah, you're welcome. So are you seeing my Google Colabs page? Can you see that?
Yes.
Okay. We want to talk about comment. How do you comment? Comment. How do you do this in Python? There are some conditions where you just have to comment some things. You just have to write the reason why you are doing some things. For example, I want to talk about let me look into a condition that I want to quickly talk about, and let me use it as an example. Coming that we echo, so okay. I've gotten something I want to talk about. Let's say I want to talk about iteration. Iteration. Are you with me? Hello, everyone. Hello, everyone.
Yes, we're here.
Yeah, you can see I put iteration here. So I want to talk about iteration. If I run these, this is the topic of what I want to talk about. I can't just put it like this, because if I run it, it's going to be a problem. There will be an error. You can see iteration. What did I mean by iteration? It means I want to talk about iteration, and I want to actually run something in the shell, or I want to run the shell. I can put a comment. And a comment will not allow that particular line of code to be executed, to be run. And now to do comment, you use hash sign. If I put hash now, so you can see the iteration I put can be there as an heading. Or sometimes you write code and you want to explain what the code means, so that anyone that have access to the code can easily understand what you are doing. So you use a comment to explain this line of code. So this is a single line comment. Immediately you put the hash in front of it, it will not be executed. It will be seen as a comment. So Python will see that anything at the back of the hash as a comment. So it will just bypass it. So since I say iteration now, I can now come and maybe use anything to demonstrate the iteration I want to run. And even if I run this shell, it's not going to be an error, because it's not even seeing it as anything, it's seeing it as a comment. So this is how to comment in Python. But this is not the only comment we can have. We can also have something like a double line comment. This is a single line comment. If I want to have a double line comment, for example, I say iteration to iterate. You can use the following. Number one, you can say you want to use Y. And number two, you want to use a while loop and a for loop. So these are the common iteration you can do. You put loop. You can put loop here. Loop. How do we use iteration? I say, okay, I want to iterate. What do we mean by iteration? Iteration means you want to perform a particular exercise, maybe over and over again, until a particular condition is set. So we call that an iteration. And now I want to explain the methods to do it. I want to say I can use while loop, and at the same time I can use for loop. Now I put this. I'm explaining by putting this in the cell. So it will not run because this is not a code. I will have an error. So the way to do it is to put comments. If I put comment here, I can as well come and put another comment here. I can as well come and put another comment here. So now if I run it, it will not be an error. All these are line comments, a single line comment. But what about if I want to like this one that is maybe I have lots of statements here, and I want to put all of them as a line, not as a line comment, but as a block comment. I can just put this thing 3 times. You can see it can be of the double quotes. So it's going to see this as a comment. So there are 2 ways to have a comment: a line comment using a hash, or using this your quote 3 times and write whatsoever comment you want to write and put another quote. So, or it can be a double quote like this of the three. Yes. So any of these can be a comment. This is how to comment in Python. So we have almost like 2 ways: a line comment which uses hash, and this other one that is not just a line comment. It will allow you to put multiple statements. So we can also use that as a comment. This is how to comment. And as we continue coding now, you will see I will be putting comments. Once I put comment, I'm telling you why I'm putting that, why I put this, why I put that. So that is how to represent the comments in Python. So let's quickly share and continue with our slide. I want to run to, let me see the slide. So that is how to comment Python operation. Last week, we talked about Python operation, the arithmetic operation where you say plus, and this plus this plus that. We talked about arithmetic operation. We talked about assignment operators, like when you say something is equals to. We talked about comparison. You try to compare if A is greater than B, if this is greater than that, or is equals to this. So we also talked about assignment comparison. We talked about logical operation, and or. If a condition is and, or if a condition is or. So let's quickly rush over that again for some people. Let's see. Our time is we just need more time for this. Please, are you there? Hello, everyone. So I want to put it as a comment now so that I can run it if I like. This becomes a comment. Trying to see Markdown. So I want to talk about arithmetic operation of plus, arithmetic operation, they are addition, plus, minus, subtraction, addition, multiplication. We talk about floor, division, modular division. We have division. You have modular. This is a floor. We have a modular division, like a percentage, like this. These two are very important, were very important to us the other time. We talked about them at length. So let's quickly record those two. Everybody knows addition, subtraction, multiplication, division. So that is not going to be a big deal. If, for example, if we have 5 divided by 2, of course, we should have, okay, let's say 10 divided by 2. 9 divided by 2, we're going to get something like 4.5. This is division. We can say multiplication, multiply. All these are easier. This is 18. We can as well say minus. So this is 7 now. So let's go to the division. We have the division and we say 9 divided by 2 is 4.5. We say if you want to use this floor division, this one is only going to take the integer part. When you say 9 divided by 2, you floor it and you do like this, it's only going to tell us it's 4. Forget about the integer part and the decimal part, that is 4. Even if it is something like, for example, we say 9 divided by, someone says approximation. No, this is not approximation. If you say 9 divided by 1.7, for example, this is, okay, no. Let me say 1.2. This is, okay, no, why? No. Okay, 2.2 rather. 2.2. Okay, let me say 2.7. 3.3. I'm trying to get something that will be near 2.03. Or something I want to point out. Yes. Please look on 2.5. That is this. If I want it to increase, okay, let me say 2.3. It should be 3 point something. 3.9. Yeah, this is what I want to get. I said 9 divided by 2.3. I got 3.91. So if you say approximation, if you want to approximate, it should be approximated to 4. But if you do floor is not approximating. Floor is only taking the integer part. So if I floor it now, double division, and I run it, I will get, it's still going to just be 3.0, taking the integer part. It's not going to approximate it to 4. And you can see if we are to base it on approximation, if I run it, normally it should be 4, because 3.9 is can be approximated to 4. So, but if you floor it, it's just going to take the integer and forget about the other part. So that is 3. This is how to do floor division. Now, we also have modulus. This is modulus. Modulus, we only take, for example, if you say 9 divided by 2, you run it, it's going to be 4.5. It means we have 9 divided by 2 can go, and 4 times, then we have 1 remainder. If we are only interested in the remainder, you say modulus. By the time you take the modulus of it, the percentage is the sign for it. So when you pick the percentage and you run it, you are going to get 1. What this is telling us that 9 divided by 2, this is going to be 9 divided by 2, that is 4. 4 times 2, 8, remainder 1. So we are only getting the remainder. So let's run another one. Let's call this one 19, for example, or let's say 27. 27 divided by 6. I don't know what that is going to be. 27 divided by 6, for example, this is telling us that 27 divided by 6 is 4, 4.6. But 27 divided by 6, that is 27, 6 times 4, that is 24, remainder 3. So if I say, what is going to be the remainder? When I divide 27 by 6, I just quickly use a modulus. So I use the percentage. I run it, it's telling me that it's going to be 3 left. There are some cases where we are only interested in the remainder. So when you are interested in the remainder, you run the modulus. That is what this means. Assignment operation, assignment operator is just equals to let's go back to the slide. The assignment operator. I hope you can see the slide, right? We have talked about all these, floor division, modulus, exponential. Of course, exponential is raised to power. Then comparison operator. The comparison operator is only telling you to compare one item and the other. Compare A and B. Is A equals to or greater than? Is it greater or equals to? Is it less than? All these are comparison operator. So you can compare. So those are comparison operator. So comparison. Then we have logical operators. The logical operators, they are of this type. A logical operator like this, like you have the first condition. Number 1 is less than 13, and number 2 is less than 4. So there is a logical operator in between them, and so we can be of and or not. So if it is and, if both conditions are equal, are correct, then the logical operation is going to be true. But if you use or, only one is needed for it to be true. So later, when we begin to run some of these our conditions, we'll be using them. You will understand them better. So we don't really want to waste time on this. Identity operator, don't bother about that. You can just go and read it. Membership operator, you can just go and read it. Then bitwise operator, forget about bitwise. It's talking about binary numbers. So we're not going to be talking about the bitwise operators. We just have to mention it. So there is a way. These are binary numbers. When you see 10, is 1010. If you see 5, is 0101. There's a way you can convert numbers from binary to decimal number. And when you get them, all these bitwise and bitwise or, there is we are only checking the bit. The first bit is 1 here, while the first bit is 0 here. So if you are running or, it means the or is going to be 1. If you are running, so there are things you do here, but don't bother yourself about this bitwise. If we have any reason, I don't think there is any reason we have to use bitwise operation in as a data analyst or this. I don't think there is going to be anyone for now. So if there is anyone, we're going to talk about them. Now, what we have to quickly rush over before our time is almost, okay, we still have like 15 minutes more. Yeah, before our time is the method. There are methods in, we use for different data types. We have talked about the different data types like string and list, dictionary, and etc. They have what is called method. So we quickly rush over this method. And you will see the importance of this method. Some of these things we have to consider is like, you have a list and you have a string rather. For example, hello world. If I want to convert everything in the hello world, I want to convert them to capital letter. There are things I can call on them. If I want to count the number of words, and then there are things I can do. If there are so many of these methods I can do, if I want to add more to it, there are things I can do. These are the methods we use in string. So we only look into them, and let me copy, and let's quickly look into some of these methods. We cannot do everything, but we just do 1 or 2, and then from there we're gonna continue. We're gonna practice when we get home by ourselves on our home. We have methods. Please, can you confirm you see my screen? Hello, everyone.
Yes, I see your screen.
Okay. So we have methods that we want to run on method on string, and on list. I think they are the most important one for us to know for now. So we want to run this method on them. Okay, sorry, I want to put comment because so there are methods, there are things you can do on list, and there are things you can do on string. You can do most of those things on tuple and every other thing, dictionary, but for now we just want to concentrate on string and list. So if you have something like my list, my string, let's start with string. My string, let me say my string 11 is equals to how are you? And I run it. How are you? So there are things I can do on this how are you is, if I like, I can, if I print it, if I count it, yeah, let me count it first, length of my string. My string 11, if I run it, what did you think will be the length? It's going to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see that there is a space here. That is why it's counted 12. My list. My string 1, there is a space. A space is counted as 12. So there are 3 spaces here. There is a space before it, there is a space in between, and if I put another space here at the back and I run it again, it's going to turn to 13. Let me run the list again. So this becomes 13. So one of the methods that we can use is like, we can look at it like, I don't want this space to be there. And there is a method you can use to do that. Let's say my list 11, my string rather, my string, I don't know why I just want to use list. My string 11 dot strip. Now you can see when I'm typing, there are so many things that are coming up. Immediately I just say my string 11 dot. You can see all these are the methods that you can do on the list. You can strip it. I actually want to use strip. The strip. And let me run it. What that will do, it will remove all the empty space before and after it. You can see now that the space before how and the space after you has been removed. So that is how to remove a space. And this we are going to be using this a lot when we are dealing with data and pandas. We are going to be using it a lot. So we have to remove it. We don't need those empty space before and after it. So we don't need them. So if we can as well call this, let's maybe instead of printing it, let's just call it something like my street. Let me assume that I've removed the empty space before and after my street is equals to, this is my street. If I run it, that is my street. If I print the length of my street, let me print my street. Of course, there are things I can do on my street now. Print. Sometimes if you just want to print, you don't need to be saying print. You can just type that stuff and it will automatically print on its own. So let me use that. By now, you should get used to that. My street will print what I have. This is it. You will see that the difference between my street, okay, let me print my string 1. So it's not always, you don't need print always. So you don't need to be saying print always. So you can see the difference between the first one and the second one is that in my street, I've removed the empty space before the starting of the word and after at the end of the word. You can see the difference. So if I run the length on 2 of them, the length will be different. If I run the length, of course, we have run the length of the first one, that is 13. Let me run the length on my street. It's going to be 2 less than whatsoever I have there. My street. my strip. So if I run this will be 2 less because that is 13. Telling us the first one was 13, the next one with the second one we have 11. Telling us that the first space has been removed and the last space has been removed. It's not going to remove the space in between. Of course, it's part of the world to space the worlds. That is okay. But it's not okay to leave a space before starting the world or a space after the world. So that is why that is what the strip method is used for. You can call on capitalize. Let's capitalize. Let's go to my strip. My strip dot capitalize. I want to turn this to capital letter. Capitalize. See capitalize. Just run it. Oh. When you are calling method, you use dot to call it. Dot capitalize. Whatever you want to do, dot capitalize. Then you put this and you run. It's going to turn to capital. So how are you? That is the first one to capital. So there is one that will change everything to capital letter. I think dot title. Let's see. My strip dot title. Dot title. Yeah, I have dot title. Let me run. So okay, the difference is that this one is only the first word that was changed to capital letter. This one, the beginning of every word has been changed to capital. Okay, there is another one. Let's see. I think there is a method that we convert everything to capital letter. My string to capital letter, my string, my strip. Dot, which method is that? If you cannot remember, you can check. Let's quickly check our method. Let's check all the method and see the one that is telling us that we convert all to capital letter. The beauty is that all these things, you don't need to memorize them. You can always have them. And okay, we have capital telling us convert the first character to uppercase. Okay, I think there is dot upper. Yes, dot upper. Yeah, upper. There is dot lower as well. Upper. So you always put this, run. So everything has been converted to uppercase. If I run dot lower, it's going to convert everything to lowercase. And so if you read all this we have, all this method, that is all you will just be doing to convert your string, if it is a string method, to convert all your string to whatsoever the functions or the method perform. That is how to run different methods on this. There are cases where you have to be running all this method. You have to, maybe you want to convert some things to capital letters. You want to convert some, maybe each letter, the first word to capital letter. You want to turn everything to small letters and things like that. Those are the methods you can use on the string. There is what we also call slicing. Let's check our slide. This may be where we are going to stop for today. And in our next class, we continue. I will definitely update this list, the list of what we have here. So please go and try some of these methods on string method. These are string methods. So go and try them. When you say is upper, it's telling us, is there any uppercase there? If it is upper, it's going to tell you it's true. Some of them are capital letter. If no, so these are all the things we can do on them. And as we code along, we can demonstrate everything at once. You are going to be seeing some of these things as we code along. Now we have the list method too. These are things you can do on string. We also have things you can do on list. You don't need to memorize them. Just practice some, and then you can always have these cheats with you. You can always have them. At any point, if you can't remember anything, go and pick them and read. As you code, you always remember them. You remember as you code. It's not for you to memorize, just for you to know the actual, the right place to use them. But to know the code, never mind, never worry yourself about them. You can always have a cheat with you to always check the code. And in fact, you can always check on ChatGPT, oh, how did I change this to capital letters? It's going to tell you, use dot capital, use dot upper, use dot lower, use this. So you can always have access to them. So, but it's just for you to know how to use them and the right time to use them. You don't have to cram or memorize anything here. Like under the list, we have dot append. We were trying to use Dr. Peng the other time. We are going to solve the problem later next week by God's grace. We are going to solve the problem next week where we're trying to input a name and we're trying to append them. Append is to add, to continually adding to a list. Clear, copy, count. Count is just like you have a list of something like we say egg, mango, egg. You want to count how many eggs you have in this list. We now tell you, oh, we now go there and count like, okay, we have like 4 eggs. We have like 3 mangoes. These are all things you can do. Pop means to remove, maybe to delete an element from the behind. There is a way you can delete. When you delete, it's going to delete the last one from behind. So, and things like that. There are things you can do on list. So I think this is how far we can go. In our next class, we're just going to start from string method. And we are not going to revert, we are not going to do the recap of all these data types again. We are definitely going to start our recap in our next class from a string method and list method, and then how to get the function, higher functions and things like that, building functions, other building functions, and things. Those are things we will be looking into. And then conditional statement. If I thought we are actually going to get there today, but I don't know how we are using our time. The time is not enough for us. So we're going to talk about if conditional statement, while loop, and for loops, and the assignment, the work we were doing, and there was an error. We are going to run it together and reason together, and we're going to look into many conditions. And next class we will get more fulfilled like this, because we are going to introduce ourselves to Pandas as well, and NumPy. Those are the libraries we use in our data science. This is the focus of everyone who want to become an analyst, who want to become a data scientist. Those are the libraries we want to get involved with. And I'm sure by next week, we're going to be talking about all these libraries. So in our next class, we definitely recap the string method and all this stuff. Thank you for your time. Please, Blaze.
Hello. Yeah, thank you very much, Abdul. Thank you, everyone. Is there any question? If you've got any question, please feel free to ask, or you can send us an email inbox info@thebdpn.com. If you've got any questions, and also, like I said earlier in the chat, we're going to email the recordings to everyone, and then the slides and every necessary information. And just a reminder that this link is the same link we'll be using every week. So just log in using this link next class. And yeah, thank you all.
So another thing I want to say, if there is any better time, we can, because I think we need more time. The 2 hours is not enough. So I don't know if there is a way we can dedicate more time, or there is any day we think we can just do a crash revision that we always make our course to be faster and for us to quickly achieve what we want to achieve. I don't know.
Okay, yeah, that's noted. I think we would include in the feedback forms and things like that, if we can all suggest, how we would like that to happen, as to if we should increase the time from maybe 2 hours to 2 hours 30 minutes official, or maybe 3 hours, depending on us all. So
I'm even thinking of if we can increase our time, maybe our time still remain the same time on Saturdays, but maybe on Friday we can have an hour class, so that that will help us to cover so many stuff. So I don't know if that will be achievable. Maybe towards the evening on Friday, if that can be achievable. I don't know. I'm not sure.
Right, that's a good one.
That idea.
I think
we
that's
have
a
gotten
good
a lot
idea.
to do. We have gotten a lot.
Yeah, please share your feedbacks or suggestion through info@thebdpn.com, and then we'll send out a feedback form as well, asking our opinions.
All right.
Okay. I have something to say. Is there a way we can practice some of the things we have learned on our own? So when we come to class, it's quite easier for all of us to follow. You know, are there resources we could refer to? And are there things we could do on our own whenever we are free?
Yeah. Yeah, we have shared the Google Colab with you. And at the same time, the resources we have now. So as what we have done so far, everything is in the slide. And I think everything is in the Google Colab. Go and practice them so that you are going to be more competent at coding with them. So try them. We definitely share them with you. The Google Colab, the one I'm using, and the slide, you can play around with the Google Colab you have. Just play around them and try some new things on your own. So
Also, would share.
I think later, if I see a very good textbook that I can recommend for everyone to always read ahead as well, apart from our slide and the Google Colab, I will recommend some textbooks so that we can always read those textbooks as well. There are lots of resources, so I can recommend, and I can share some other textbooks, with you.
That'll be helpful.
So thank you.
Right, guys. If no more questions, then can we call it a day now? Okay, bye everyone. Enjoy your weekend. See you all next week. Bye, Abdul.
Okay. Yeah. Thanks, huh?
All right, bye.
So we talk later, right?
Yes,
Okay.
definitely. Yeah.
Yeah. Thanks.